Hi, this video will talk about inverse functions and one-to-one. So in order for a function to have an inverse, it has to be one-to-one. The easiest way to determine if something is one-to-one is to graph it and see if it passes the horizontal line test. So we're going to do two examples in this video. The first one, number 16, is f of x equals x squared over x squared plus 4. And the second one is number 20, f of x equals 5x square root x minus 1. And now to graph, and you'll need to be able to graph throughout this semester, but the easiest thing that I use is geogebra.org. So you go to www.geogebra.org, and you can spell GeoGebra G-E-O-G-E-B-R-A. And now I'm just going to enter my function. To use GeoGebra, you have to enter it in function notation. Okay, I'm going to make my screen just a little bit bigger, my font size a little bit bigger, using this option here, just so you students can see it a little better. And now I enter my function. All right, the first one was x squared. To do the squared, I use the caret. In other words, the symbol above the 6. So that's representing x squared divided by, again, just using the slash, x squared plus 4. And now GeoGebra will graph it over here. The really cool thing about GeoGebra is if I put my cursor in the window and use my scroll button on my mouse, then it'll zoom in and out. I can pick it up. If I hit this button here, I can pick it up and move it all around. So it's kind of nice with that respect. And now we're going to apply the horizontal line test. The horizontal line test says if there exists a horizontal line that passes through my graph in more than one point, then it is not one-to-one. So to show you that, for example, I'm just going to graph y equals a half. Okay, again, notice I have to use function notation, so I'm using h of x. But that's the same thing as y equals a half. All right, and now just to exemplify the point, I'm going to go to Object Properties, change the color to blue just so we can see it. And now let's make it a little bigger too, so that we can actually see it. Okay, so here, notice the horizontal line test. I've drawn a horizontal line and it goes through my graph, the black line here, at more than one point. So I would conclude that the function x squared over x squared plus 4 is not one-to-one. And what that means is that the inverse does not exist over the entire domain. Okay. Now let's look at our second example, 5x times the square root of x minus 1. Again, I'm going to go back to GeoGebra. If I wanted to, I could delete those out, but I don't have to. If I name something the same thing, it'll just save right over it. So it's 5x, and then square root is sqrt x minus 1. Notice I want to put that in parentheses. Okay. Well, I think that it's asking me for a multiplication sign. Okay. And there it goes. All right, notice now I've got my horizontal line there, but as I zoom out even larger and larger and larger and larger and larger and larger and larger, that there does not exist a horizontal line, okay, no matter where I move it, all right, that goes through more than one point on this graph. So I can conclude that the second one, 5x times the square root of x minus 1, is in fact one-to-one, and therefore it would have an inverse. All right. So now once we graph it and determine if something is an inverse, we have the definition of inverse here. And we have to know a little bit about compositions of functions. The definition of inverse says that if I have an inverse and stick it into the original function and evaluate that, I'll end up with x. In addition, I have to be able to take the function itself and stick it into the inverse and evaluate that and also end up with x. And I'll show you what I mean in a minute. In order to find an inverse, we first go from function notation usually, where we have f of x, and replace f of x with y. And now we usually have our function in terms of x and y. We want to solve that function for x, and our final step is to replace y with x. I have two examples that I'm going to do for you today. Okay? The first one is find the inverse of f of x equals 3x. Let's recall our steps. Number one, I'm going to replace f of x with y. So I'm going to have y equals 3x. Number two, I'm going to solve for x. So I'm going to divide each side by 3. I get that x equals y over 3. And now for my last step, I'm simply going to replace the y with an x. So now I know f inverse of x is equal to x over 3. Let's do one more example. This example is number 26. That was 24 from our text. Okay? And we have f of x equals x cubed minus 1. Again, step 1, replace your f of x with y. Y equals x cubed minus 1. And now we're going to solve for x. First step, add 1 each side. Y plus 1 equals x cubed. Next, I'm going to take the cube root of each side. Over here, I'm left with x. And over here, I'm left with the cube root of y plus 1. But now my final step is to replace my y with x. And I get the cube root of x plus 1 is equal to my inverse function. And now let's just show you composition of function and how our definition of inverse corresponds to that. So if it's truly an inverse and I take the inverse and compose the original function of that inverse, then it will equal x. And in addition, if I take the original function and stick it in the inverse, then that should equal x. And now I'm going to demonstrate this with our simplest example. Recall that this is a composition of function. This is not multiplying. And what it means is that I'm going to find f of f inverse of x. And I know that that nomenclature is really confusing, but what it means is I'm going to take the inverse function, evaluated at x, and plug it into the original function, f. Okay? So here's my inverse function, and now I'm going to go to my original function, which is f of x, and wherever I have an x, I'm sticking in the inverse. Okay? So f inverse is going to equal 3, and now in place of this x right here, I'm going to stick in this whole thing, x over 3. And now notice if I evaluate that, the 3's cancel, and I'm left with x, just like it should from the definition. Similarly, if I look at the second one, and both of these have to be true. If one is true, that doesn't matter. For it to truly be an inverse, both of these have to be true. So the second one is that if I take the original function and stick it into the inverse and evaluate it, I will also end up with x. So let's look at that. So now I'm going to take the inverse and plug in the original function. In other words, I'm going to take x over 3 and plug it in here. Okay? I'm sorry, I said that wrong. In other words, I'm going to take 3x and plug it in here. So if I do that, I get, here's my x, so I'm plugging in 3x. I get 3x over the 3. The 3's would cancel and leave me x. So notice that when I find my inverse, it satisfies the definition of inverse function. Okay? And if I go through the same exercise over here, and plug the inverse into this function, you can see it would cube this, give me x plus 1, then I'd subtract 1, and I'd be left with x. Or if I take this function and plug it in here, I would end up with x cubed minus 1 plus 1. The negative 1 and positive 1 would cancel out. I'd end up with the cube root of x cubed, which again is just x. So you might want to try that on your own. I hope this helps with inverse functions. If you have other questions, just let me know.